Test, test, test. Welcome, ladies and gentlemen, to the design presentation of the DUT26. Before I introduce myself and before I start talking myself, we will start with a short 20-minute documentary about 25 years of Formula Student Team Delft.
Major leaps from lightweight to electric to aero packages to autonomous. This is 25 years for me, students.
Hi, this is Alexander de Boer. I'm René, new team manager of Formula Student Team Delft. I have some questions. Hi, you're Alexander.
Yeah,
Hi, nice to meet you. Hi, René. All right. Well, being the founder of Formula Student Team Delft, how did you guys start?
It started 25 years ago. I was studying aerospace engineering and I was looking for a subject for my master's thesis. So I went to my professor and he said, well, it might be fun to design a car for this competition.
It was instant, like love at first sight.
Yeah. And also the first team members, they also loved it, so that was not a problem. We finally got a workplace at TNO and somewhere else, and it was all scattered over the places where we could work.
Yeah, so it started off with a group of very motivated people. And
yes, the original name was Delft University of Technology, Formula SAE / Formula Student Racing Team.
Wow, it's a long name.
Yeah. Also, we didn't have a car. We didn't have any data. We had a piece of paper and we started drawing. We didn't know how big the car should be. We didn't know which kind of tires we should have, or what engine or anything. So we must apply our knowledge to make not a normal car, but a very good car.
And that's why we instantly started with a carbon chassis.
You know, the Formula 1 was way ahead, and I thought, well, we could do much better. All the other teams, they saw us and said, that's your first car, and it looks already so good. So we made a big impression, and
little pat on the back.
We set the standard for the future cars coming.
And there she is.
Yes. Yeah.
Betsy, I heard.
Oh, this is the picture I talked about. So at the end, in Birmingham, we had the prize. Mm-hmm. It was the first runner-up Rookie of the Year. So this is me. I used to have hair, but because of winning the prize, having a car, I said if I achieve it, I will shave my head bald.
Oh, I thought it was the stress.
No.
Yeah, DUT, Delft University team, first dream team, of course.
Yes, it is.
Was that already in the first year that we were instated as dream team?
No.
Okay, that was after.
The team, the name Dream Team became later. It was something really special. That's what's happening. A group of people with an idea.
With a dream.
With a dream, yes.
Wow. And it turned out amazing.
Yes.
We have a lot. It's almost no place for anything else right now.
Oh, cool. Brings back memories.
Yeah, is it similar to the Dream Hall a little bit?
Yeah, same but different. But it's really nice to see all the cars.
Yeah, I can imagine.
Yeah. Wow, cool.
She's pretty, yeah?
Yeah? she's been used a lot this month.
Yeah. Yeah, they took her out for drivers today, for driver selection actually.
Oh, cool.
Yeah.
Yeah.
So what are the cars you actually drove?
Actually, the cars I drove was the 01 up until the 08. So I've driven 8 cars. Of course, the 01 is like the first one, so that's always going to be the favorite.
Yeah.
The 04 was really quick. It was our first really lightweight. It was like a go-kart. The 04. And obviously the 08, because we became champion with that FSD. So.
And the 04 was the one without the siding section.
That's right, yeah. They said, well, no way this is legal. And they measured everything, and all the judges and scrutiny said, yeah, you're on the limit, but it's legal. But soon after that, the rules were changed. And we actually called them the Delft rules.
Yeah, being in the team from start to the DUT8.
Yep.
How did the Delft concept, the winning concept, how did that came to be?
Yeah, so we did the first 2 years with, well, sort of regular 4-cylinder cars, heavy. So we had, especially at the beginning of the 03 season, we had a big team meeting. And the team manager, Arnold Westenberg, he got up, he got a marker, he walked to the whiteboard, and he said, okay, this is, and he wrote down 125 kilograms, 125 kilograms. Everybody started laughing. He said, no way, impossible, we cannot do it. And then we started thinking, okay, what about changing the engine? Because you go from a 60 kilogram engine to a 35 kilogram engine, and then you can change everything around it, you can make it more lightweight. And in the end, we didn't manage the 125 kilograms, but we managed 137 kilograms. We went to the UK competition, FS UK, and all the judges walked around with the design report, and it was all of them marked 137 kilograms on the front with an exclamation mark. And we won the design competition. That's actually the birth of the Delft concept. Completely new, making use of materials, lightweight materials, carbon fiber monocoque, all the way through. Whole weight management system. Everything was measured, put on scales. And that takes a lot of effort, but in the end, every gram you don't have to put on a car, it makes you faster. You can almost feel the potential. When you're driving the car, you can just absolutely feel the difference, and you can say, okay, this is a fast car. If we finish everything, then we will be, sooner or later, we'll become champion. The potential that we saw in the lightweight concept, a lot of other teams came to acknowledge it, and they saw the same advantages as we have. So you could see also, we didn't just have impact on the rules and judges, we had impact on other teams as well. And they actually said, okay, this is something that we can take as a basis and then develop it further. I had the luck that I could do a couple of rollouts as well. It started out as just an idea, but I thought, okay, maybe try to do a couple of donuts on the market, and it turned out really well, and the audience liked it as well. Especially if you have the steady state donut, then you can just raise one of your hands and just wave to the public, so you leave a couple of marks.
From Student Team Delft. We're on the way. I'll see you in a little bit. All right, bye-bye.
Yeah, so in the early years we were in an old shed somewhere at the backyards of the university, and then at some point we entered the Dream Hall, which was this really big manufacturing floor with a lot of machines. We had our own office, our own space. We could enter there 24/7. I think that was one of the main advantages of the team. We had our own little kitchen where we could cook our own meals, and we basically lived there. The year we switched to electric was the second year that the electric class was introduced. Yeah. So the first year we decided not to participate yet. Yeah. Because we wanted, after the DUT29, who was supposed to win but also failed, the team had the feeling we wanted to take revenge and build the ultimate last combustion car. And the concept got perfected. The Delft concept, the famous Delft concept, lightweight, very agile car. I think that the 10 was the ultimate expression of that. And then after that we won it. We won almost everything. So it felt like we accomplished it, and there was not much more to gain for us. And the goal of learning faded away. And also the competition is really about the learning experience. It's not about the winning. So we decided it was time for a new challenge, throw ourselves into the deep again, do something completely new, and have the maximum learning experience from that. And it was only, I still remember, 10 days before FSUK, the first competition, that we had our first meters, just 10 days before the competition. So that was the first time finally the car could drive. But immediately it was really fast. I realized at that moment we could actually win. Yeah, the previous years the team has been doing really well, very successful. And now we started with this new electric era. We immediately showed again that we could win.
Hi.
Hi, Anton. How are you?
Not too bad. How are you, Renee?
Thank you for taking time today. I'm excited to talk to you. Because you were the team manager of the DUT22. How did you get involved with Formula Student in the first place?
Well, when I finished high school and started looking for universities, I sort of knew that I was moving to the Netherlands. My dad had actually read an article that Delft had just won this thing called Formula Student. They had just won FSG. And he sent me a link, and I saw that car, and it was like, I knew I'm going to Delft. The 11 was a two-wheel drive electric car. Then 2012 went to four-wheel drive. It was successful enough to set the world record at the time for the fastest accelerating electric car, 2.15 seconds. Then 2013 continued, but added some aero to the car for the first time since the first car. But this was now a serious aero package, made it look a lot more like a Formula One car. 2014, we went to our, at the time at least, revolutionary inner wheel motor concept. It was a very difficult concept to get right. So 2014, we couldn't win FSG, but 2015 was one of our most successful years ever, where we really got this inner wheel concept up and running. And it's still essentially the same concept that we're running today.
What I'm hearing is we were quite early to adapt on aerodynamics, but I think it was around 2017, 2018 when autonomous started to kick in, but we adapted that quite late. Do you know around that time period why?
I'm not 100% sure why, but I can hazard a guess, and I think it's because we've always been fully focused on winning the biggest competition in the world, the biggest student design competition in the world, right, which is FSG. And we want to win the biggest part of that competition, which still today is the part of the competition which includes having a driver in the car. And by adding an autonomous vehicle to your roster, you're necessarily going to be detracting from the main goal, which is to win the top competition.
We laid down the basics for the autonomous system, even though we were quite late, because we worked together with MIT in the A team.
Yeah, that's true. We had two teams running next to each other. We had DUT19, and then we had DUT19D, which stood for driverless. And they took the 2018 car, and they ripped most of the aero off. They got the biggest, most powerful computer they could find, and they bolted it to the back of the car. And then they set up this partnership with MIT, and we actually competed in the driverless competition at FSG, and almost did really well.
If we circle back at the autonomous part of it, that was going to be a really, really big thing in DUT22. What happened, and how did the team deal with that?
Yeah, that was brutal. That was one of the toughest decisions of the year. So let's see. So 19 had done autonomous. 2020, COVID came along. 2021, a lot of recovery from the COVID. We had moved facilities. It was going to be an exceptionally challenging year, and so they made the decision to not continue the autonomous program until we were back on our feet. And then 2022, 21 nailed it. So 22 could go for it. We could take the gloves off and sprint again. At Formula Student Netherlands, we've got this car with some gremlins, let's call them, some reliability issues. And then we thought to ourselves, okay, there might be this brutal route where you drop the autonomous, which means 7 or 8 guys who have spent the entire year pouring their heart and soul into the autonomous system. An excellent department, brilliant full-timers, brilliant heads of the departments. They have to be told a month from the finish line that we need to drop it. We need your skills, all its time available into getting the car as reliable and quick as possible. And that, we felt, gave us the best chance of winning. And in hindsight, I think we were right. I think it was the right decision.
How did you even tell those people? Where do you start?
That's where some of these legends of DUT come. And I remember we, myself and Andrea, the chief electrical systems engineer, we pulled Olaf aside and we explained all the logic that I've just explained. And Olaf went quiet for a minute and he said, look, is there room for discussion on this? He said, not really. We thought about this for a few days now. I really think this is the best choice. Olaf said, okay. And he took the afternoon off and he came back in the next morning and he walked up and he said, how do we win FSG? And he went after it. And wow. He took charge of running the, Jesus, I'm teary-eyed thinking about it. It's spectacular. It's unbelievable. Imagine, you get your year ripped up and you come in the next day and you say something like that. And he went after it. So our goal was to win FSG with the fastest, most consistent car built by one united team, AHU. And we didn't. We failed because we did not win FSG. Our car stopped due to a bug 3 laps from the end of endurance. So no, we didn't achieve the goal. But the secret about the team goal, of course, is that the goal and the purpose are 2 different things. You need the goal to fulfill the purpose, and the purpose is to become better engineers and better people. I think we excelled. So we failed in the goal, but absolutely achieved the purpose. by far the most spectacular year of my life. My worry is that I might never have a year that spectacular for the rest of my life. The thing that you always think back on is the people.
Hey, you're leaving already?
I am leaving already.
Yeah. What a result, huh?
It's been an amazing year. Wow, what an amazing car.
I saw. I have big shoes to fill.
You'll be fine, Sammy. Don't worry.
Good.
All right, I gotta go.
You got one more piece of advice, though?
Of course. Be agile. Enjoy it. It's gonna be a fast year.
I can imagine.
You'll love it.
All right.
Bye.
See you later.
All right, ladies and gentlemen, you already saw it. My name is Sammy Chaitin, and I'm the team manager of Formula Student Team Delft for the DUT26 season. And I'm honored here to stand here today before you and explain the story of the newest team sitting right before you, the DUT26. Now, a quick raise of hands. Who knew about the team before this documentary? I hope you guys did. Who knew about the team before hearing it from their sons or daughters? A few hands. Not too shabby, not too shabby. Well, a question that might arise even after watching this documentary, because there's more to say, is why? Why do we do any of this? And it's very simple. Passion. All of these students before you have one passion, and it is building this car. It also includes all the fun we have along the way, and of course, all the learning. Because the purpose of Formula Student Team Delft, as Anton very beautifully said, is to learn and become better engineers. Now, with my role in the team, I'm able to witness the motivation of these people firsthand. And it helps me get up in the morning and make sure to deliver my part in making sure this team achieves its goal. Because people often grasp when I tell them everybody here is on a voluntary basis. What? Voluntary? You spend your full time here, a whole gap year, on a voluntary basis? Well, yes, because of the passion. When you are passionate about something, nothing should and could stop you. And I'm very happy to be part of an association which provides the platform for many of these students to express that passion. Now, passion alone isn't enough. There's more. In order to achieve our goals, and also the team goal, we need to foster community, cooperation, and skill. And for these things, we have our association, our partners, and most importantly, each other. The DUT26 team has set out to do the following: to win FSG with a cohesive team and a well-understood, reliable car. I will elaborate on this team goal in a bit. That brings me on to the next question. Who? Who on earth is going to do all of this? And the obvious answer is the team sitting right in front of me. 87 people. Can you believe that? 87. And not only is it only 87 people, it's also 25 different nationalities. And that brings its own challenges. Of these 87 people, we have 30 full-timers. And of those 30 full-timers, we have 12 core team members. These are your technical chiefs and your management team. Now, this year I've become very good at remembering names, but it's also leading this team has also been the most difficult thing I've done so far in my life. And luckily, I'm not alone, because I have a very strong core team next to me and very talented engineers. Together, we keep each other sharp, and we make sure that we can achieve that ultimate goal. And looking in front of me, I have full faith that we can do that. Now, there's more to this, because we have a whole community backing us up. First of all, our alumni. In total, roughly 1,120, of which 185 are still active. And these alumni have been in our shoes before, and they're here to help us and encourage us along the way. They're here to make sure we don't repeat the mistakes they made, and we can extract the most potential out of ourselves and the team. Without them, it wouldn't be impossible, but it sure as hell would be more difficult. And I think there's a great lesson in that, because if you want to succeed in life, there's no reason to do it alone. If anything, it lowers your chances. Look at me, for example. I'm not an exceptional engineer. I'm fine with saying that. I'm certainly not exceptional in Google Sheets, as some of you in front of me may know. But what I am good at is talking and coordinating with people. And when I accepted that and trusted my colleagues and these engineers to take care of the rest, success was again a little closer. Now, the final piece of our community are our partners. Because of them, we are able to fund this whole project and make sure that car is actually built at the end of the season. Our biggest partner, our main partner, since last year is Shell. Without them and without their support in many ways, last year and this year would not have been possible. They continue to be our main partner, and we hope that they do so for a few more years. It saves us the headache. This year is totaling 116 partners, of which we have both in-kind partners who provide us with production, such as our motor housings. They provide us with transport or our accumulator cells. And we also have partners that do monetary support in order to cover for our operational costs and parts of our car that are not easy to do in-house. Now, this year, we have a few new additions. One of them, Hyundai Motor Group. It's our first original equipment manufacturer in 4 years. Volker Steven NL BV, more commonly known as Volker Wessels. And the biggest addition to our family, one you are all familiar with, ING. And we have actually someone here from ING today to talk a little bit. Please welcome Guido Smit. Welcome, Guido.
Thanks.
Could you tell us a little bit first about yourself and what you do in ING?
So Guido Smit, responsible for engineering and reliability. Obviously, if you do engineering really, and then really well, reliability is not an issue. That's not always the case, so I really try to mix looking after engineering best practices, really focusing on standardization in ING, and then hopefully reliability, once again, comes by itself. But I also do a lot of incident management, unfortunately.
Could you tell us a little bit about why ING chose to partner with us this year?
Yeah, so in ING we often have discussions on how can we be more social responsible, how can we give back to society, etc., etc. And then we met in Davos, I think, or at least you guys met with the CTO of ING, Daniela. And then we started conversations, what can we do, how can we help? And I think in the end, you can be really proud in having this partnership.
Yeah, and we are very thankful also for you guys. Could you also tell us a little bit about next year's and what the plan looks like, if there is a plan?
So I think it's mentioned a few times, right? That's innovation. And if I look at how you guys innovate, I think that's something we at ING really can learn and benefit from. So that was actually for me the first thing I thought. These guys built a car in a year. It takes us a year to sign this contract. We need to learn and we need to adopt this speed, right? The key, especially now in banking, is speed. So we need to learn from that. On the other hand, I think having roughly 20,000 engineers in ING worldwide, we can also give a bit back in engineering best practices, how we do things. And we run similar, and compared to you, we run the stack end-to-end. From the app towards the data centers, we do everything ourselves. And that's really similar to you. That brings a certain mindset that takes or brings also a certain ownership. And I really believe that we can find common ground in there.
Thank you for talking here today, Guido.
Cool.
We're also very looking forward to...
good luck to all of you, and hope you win.
Thanks. Big applause for Guido Smit and ING. Now, I've covered why, and I've covered who. That brings me to how, and I promised I would elaborate on the team goal first. To win FSG with a cohesive team and a well-understood, reliable car, AHU. Anton said it already a little bit, and FSG is the biggest and most competitive competition, Formula Student competition in the world. And why do we aim to win it? Well, simple. Delft hasn't known anything else. And in order to do so, we believe we need a cohesive team, because without it, any small setbacks, and I know for sure we've had already many this year, would crumble any hopes of achieving that team goal. We need a well-understood car, and in order to do that, we need documentation, validation, and testing. Because if you don't understand your own car, you cannot get the maximum performance out of it. And finally, we need a reliable car. The competition has become so competitive over the past years that not finishing a single event already loses any hope of getting a podium. Now, what does a Dutch year look like? We start in September with research and analysis. Here, the engineers are tasked with finding out what all the functions and requirements of their part are. Then we move to design. And in design, we have again 3 phases, which is first, concept phase. Here, the engineers find possible solutions for their design problems. Then we have preliminary design. Here, one concept is chosen and worked out. Bless you. And the final phase is detailed design. And here, the full product is finished and made production ready. And then it's production. Speaks for itself. All the parts are made. And during production and at the end of production, we start assembly, making sure that our whole car is in one piece. And then we go to testing, because this is where we are able to extract a lot of the performance in the car. And the first thing I always think when looking at this is, what a bunch of lunatics. They want to squeeze out a whole car in just 1 year? Well, yes. And looking in front of me now, I think we can do that again. Because with a strong team like this, it is not too hard to achieve that team goal. However, the year keeps having its challenges, and it is always a challenge to make sure that this planning is actually kept to. It is a balancing game between money, time, and quality. For money, we have our business manager, who gatekeeps that part. He makes sure that we actually have all the funds, he makes sure that the engineers are aware, and he makes sure that we can build this car with the cheapest possible solutions. Then we have time, for which we have our project manager. He makes sure that these students actually keep to their deadlines. And I know that is the hardest thing for us to do, but with intermediate steps and clear communication, we can squeeze out that car. And finally, we have quality. And for quality, it's fairly simple. If you don't have a high-quality car, you can say goodbye to all those podium finishes. Because in the end, do you want a car that is cheap and fast? You have low quality, not fast. Do you want a car that is quick and high quality? You need to throw money at the problem. Unfortunately, we don't have infinite budget. Or do you want a car that is a car that is cheap and high quality? You need to take your time, of which we don't have any. We just have a year. And to make sure we actually win, it all boils down to a balancing game. Now, I've talked about the why, I've talked about the who, and about the How? That brings me to where. Where on earth are we going to race this thing? Well, you can see we have quite a selection to choose from, but we're going to stick close to home. We're going to FS Switzerland, the first time Formula Student Team Delft will be there. We are going to FS Czech, and we are going, of course, to Formula Student Germany. Now, the first two competitions are meant as a sort of warm-up. We need to make sure we are on our best so that we can actually perform at the final competition. And these competitions are all built up roughly the same. They have 1,000 points, and much like Formula One, these competitions consist of a big rule book that each team needs to comply with. Before each event, before the whole competition, the team needs to go through scrutineering. This is where your car gets checked for legality and safety. If you do not pass, you do not race. Afterwards, the competition is split into two categories, the statics and the dynamics. Now, the statics starts with business plan presentation, and as the name suggests, the team is tasked with making a valid business plan and presenting this, gathering investors, and this business plan is revolved around a part of the car or system of the car. Then we have cost and manufacturing, for which the team is tasked to calculate accurate numbers for costs, emissions. They also need to consider production, they need to consider risk, and they need to consider changes in those environments, like budget cuts or emission targets. Finally, we have engineering design, and this is, as the name suggests, justifying all the engineering design decisions the team has made. And these three are here because the competition wants to challenge the teams and show how they contribute later on to the engineering industry. Now, after the statics, we have the dynamics, and this is where the actual racing happens, the fun stuff. And it starts with the skid pad. We also have a driverless option, and it's basically a figure of 8 where the handling of the car is tested. Then we have acceleration, which speaks for itself, also in the driverless variant. And we have an autocross, and this can be compared to a qualifying lap from Formula One. And to show you guys how fast these cars actually go, because I think it wasn't really clear from the documentary, here's a quick autocross lap from 2019, FS Austria. For the audience, trust me, this is not sped up. The final events, endurance and efficiency, those two are combined. And this is basically your Grand Prix. And it is also the most amount of points, which means not finishing here loses any chance of the podium. Now I've covered the why, the who, the how, and the what. No, sorry, the why, the how, whatever. This is the DUT26. Good luck, buddy.
Wow, what an amazing car. A year in Formula Student Team Delft is marked by right around 1 million mistakes. 173 days ago, this group of people in front of me walked into the workshop not knowing anything about each other, what they were going to do, or what the end result looks like. Now, everything you do in Formula Student feels like 2 steps forward and 1 step backwards. But if you do that 1 million times, you still get 500,000 good steps. And 500,000 good steps get you to a car like this. Now, here in front of me, after that, sits a group of people that are, as you might saw from the team goal, cohesive. They help each other out, they have each other's backs, and they all strive towards one common goal, to become champions at the end of the year. But what you need for that is to build a nice car. To truly appreciate what we have done this year, we first need to take a quick look at the 2 previous cars. The previous years have brought us an immense foundation to continue building on, but they had one minor flaw. You don't need to be a vehicle dynamics expert to see that the behavior on the left here is non-ideal car behavior, because having all 4 wheels on the car is quite nice. Now, you can solve this in quite a few ways, but with the experience that we had in our alumni, in our chiefs, and in our engineers, we chose to do this by redesigning our suspension and going back to the DUT concept, the lightweight car with a low center of gravity and good suspension. For that, we decided to completely redesign the suspension system. The old dampers that we used didn't work, so we went to our damper partner and asked, hey, can we make new dampers? Now this system has changed, where usually you have 1 damper per corner, managing a lot of systems. Now you have 1 separate damper for your 2 modes in a car. Pitch, where the nose goes down when you're braking, and heave when the car is going up and down. And for roll, when your car's wheels are independent of each other. Now you can tune your roll behavior and your heave behavior separate from each other, which gives you much more control over what the car is going to do in cornering, bumps, and hard braking, giving you a much more defined aero platform, and hopefully keeping all 4 wheels on the ground at the same time. But if you're keeping all your tires on the ground, then you want some extra pressure to put them down. That's where our aerodynamics department comes in. For this year, there were some rule changes, some setbacks for the department. The rear wing got cut off, and they had to scramble to get everything back. So we decided validation. We need to make sure that we know what we are doing and the package is actually doing what we want it to. So we went all in on testing. What you can see behind me is PTV testing, where small particles are shot at a driving car and are tracked for speed and velocity, where you can see everything important for a nice aerodynamics package, and we check with the models if what is happening there is actually matching what we simulated to get an even better package. For this validation, you can also put the car in the wind tunnel, where you can see with your own eyes how the air is flowing. A very, very bizarre experience to have in real life. But at this point, all 4 tires are on the ground, and it's being pushed down by the aero package. That means we can get some torque in it. Our wheels are spun by the drivetrain, the part between the motors and the wheels. In this, last year had a complete new redesign. They designed a new system to get more grip out of the new tires. System worked throughout the entire season, and we, as management, made the foolish assumption that that means that the system was correct. About 13 kilometers after the car was finished, the system broke, and we decided, oh, we cannot just move on with this system. We cannot simply take a system that is faulty and move on. In this, we had a wonderful sit-down with our engineers where they admitted, hey, we cannot innovate further. We have to take a step back, look at this system, and actually get it working, reliable. It's very similar to what Anton said. It's putting aside what you wanted for the best of the team. At the end of the day, they put down their work for 3 weeks, researched every single part about what was faulty on the car, redesigned the old system, and still got the weight down by 20%. They still achieved their initial goal, even though they stopped designing, they chose to go back to the old system and got it to work. The same happened for our pedal box. The same group of engineers deciding the old system isn't working, we have to go back and still managing to make it work. It's an incredible experience to see your engineers growing and putting the entire team above their own wishes. Amazing. Then, you've got your wheels spinning, they're pushed down, they need some power. Our powertrain department, or everything cooling and delivering power related, this year decided to go the research route. A completely new system that hasn't been tested yet in our cooling loop, with new materials and new geometry to get our motors and inverters, the thing that turn your direct current into alternating current in the motors, extra well-cooled and way lighter. Also, with some nice packaging in the accumulator, the big battery that gets all the power for the car, a 10% weight reduction is realized without having to go any innovative new materials or new cells, just by some standard good engineering practices and focusing on that DUT mentality of getting the weight all the way down, they still manage 10% less. But even a low-weight car that has everything down and has the tires on the ground and a lot of downforce, it still needs to be controlled, where our electronic systems come in. The electronic system is kind of like the nervous system of the car. It's got the brain in there, it's got all the sensors in there, it's got the actuators in there. It's like your whole control unit. And for this year, a DC-DC converter, which takes the high voltage from your accumulator, 600 volts, and brings it down to a lower voltage where all the other systems can work on. Think of it kind of like your phone charger. You plug it into the wall, and it outputs 5 voltage, which is what your phone needs to charge. Next to that, the base station. Old cars rely on a SIM card in the car to communicate with cellular devices, just like your phone, to get down to our server. Now, you might know if you're abroad, your phone doesn't have great reception. If it's your phone, it's annoying. If it's our car, it's a safety issue. So the base station is developed to get direct communication with the car so that in any circumstance, we still communicate with the car and can read out all safety critical issues. Cell voltages, cell temperatures, any errors the car is throwing, even in poor reception areas. Then, the dashboard. Even in case this falls out, the dashboard can be used to directly communicate between the driver and the car for any issues. Think of it like the dashboard on your car. It's giving you important information, the check engine light, and some useful things if you want to tune them, yes or no, like the noise of your music or of our communication. Then, if you've got all of these loose parts, you need to stick them together. And sticking them together, we build our own beautiful carbon monocoque. For this, production was a hassle. A new concept in all of these things, suspension and drivetrain and pedal box and everywhere, especially suspension, required the chassis shape to be completely redesigned to match with all the intentions that we had at the beginning of the year. This means you need to make new molds. I think this photo was taken at around 2 at night, when they were finally done with the infusion. These people have pulled through. But also, to accommodate all the other things, getting the mass down as low in the car so that you don't have the unideal car behavior of being on 2 wheels, packaging the most heavy parts of the car very low in the car, and the lighter things up makes your car way more stable in all operating conditions. So it's a bit of a double whammy. New suspension and everything else, all helping towards the same goal of winning FSG at the end. But your driver also needs to survive. So for this year, the seat of the driver, where the driver is mounted, is integrated into the car and into the fire safety systems. This way, the driver will move around less, so it's not really for their comfort, it's for car performance. And the steering wheel is made in such a way where the driver can more intuitively tune all the things that are now visible on the dashboard. All in all, this gets you a very nice car, a very good control system, good aero, everything is nice and planted, but those brains of the car can still control some things. Here you see an example of a new system in controls. On the left, you see the traction control mounted on the main instance of the computer, and on the right, you see it mounted on the traction controllers. On the right video, you saw almost no wheel spin. On this video, you see quite a lot of wheel spin. If it would play. That's unfortunate. There you go. On the right, you see very little slip, and on the left, you see a little bit more slip. Again, not entirely ideal. You would like your tires to have some grip. In this, it's traction control mounted on the motor controllers. So motor controllers, the things that are using DC to make AC in the motors, are communicating directly with themselves to get the traction control working. Previously, you'd have to communicate with the motor controllers to the brain of the car. There's a little, hey, I'm having a lot of slip right now. Oh, you should probably quiet down a bit. In this communication, you get a lot of losses, which is what you see on the left video. If the system is communicating with just itself, that little game of telephone is eliminated, and the system works much more efficiently. Now, with all of this, you have a great car, but you're driver limited. So, this year, we are innovating in a completely different way. A driver-in-the-loop simulator, a training device for our driver. It's basically a video game where the driver can do as many laps as they have time for and as many laps as they want. Well, as many laps as we want. And they can get the entire performance out of the car without having to have a car available all the time to go testing. Because, as you might have heard already in the docu, sometimes testing days are limited, and useful testing days are even more limited. But we don't just have human drivers in the car. We also have the autonomous system in the car, which can be trained and optimized with the exact same set of systems that we use to train the driver. You have one set of truth, and you train both of your things on there, which means they will always match better, and you have infinite testing time for your autonomous, because your autonomous system doesn't get tired. Let's quickly talk about that autonomous system. Track drive. And here, the big innovation points, trying to get every nook and cranny of performance out of those two events you saw in the EV Cup, the skid pad and the acceleration, but also looking to go for something new, the track drive, which is just like a normal race, except there's no driver in the car, and it's just driving itself. A very hard system to implement, but something that our autonomous department is working hard towards, and can be greatly helped by the previous system, the driver-in-the-loop simulator. And that's about it. You have a car with all of these things. You have a car which can achieve your goals. You have a well-understood car, everything has been researched. You have a reliable car, because it needs to be well made. And you have a cohesive team. Thank you so much for your attention. I would like to thank especially our partners for being here. Without you, this would not have been possible. I would like to thank all the friends and family for their attention. This is what your friends or children have been up to. And I would like to thank this wonderful team. Without any one of you, this would not have been possible. Thank you very much. All of you can come up on stage for a photo. Ja, dat zullen we eerst foto maken?
So I can't stop.
Yes. All right, ladies and gentlemen, thank you very much. There's drinks up in the cafeteria, so have fun, go talk to each other, and thank you for being here tonight.
so I can't stop.